Awesome. All right. Excited to be here today at ETHDenver. It's my fourth ETHDenver. Excited for this panel, Restaking Revolution. We have some amazing panelists here. I figured we'd start off by doing some quick intros. My name is Alexis Johnson. I'm the co-founder and CEO of Lightnode Ventures. We are a venture studio and advisory firm based out of New York. Sydney?
Hey everybody, my name is Sydney Lai. I am one of the co-founders and CTO of Gaia. What we do is we provide developers to build AI applications that you can have potable context and memory for your AI applications.
Hi everybody, I'm Sreeram, founder of EigenLayer. EigenLayer is a mechanism for building verifiable services.
Hey everyone, my name is Jake. I'm the co-founder of a project called Layer, the best name in crypto, just Layer, terrible SEO. We make something called Waves, or WAVS, WAVS.xyz. It lets you easily build decentralized off-chain protocols. It lets you easily make AVSs, and we need more AVSs. Let's go.
Hey.
Awesome. Okay, so our first question is a little bit broader and more intro topic, but for everybody here and for audience members that are new to the concept of restaking, how would you define restaking in simple terms, and how does it differ from traditional staking methods?
That's for me. Okay, I'll take it. Restaking. The idea is when you stake, you're making a promise that you're going to run a network correctly. That's what you're doing. Restaking is the idea that when you're staking for running Ethereum network correctly, you're also promising that you're running a whole bunch of other networks correctly. You choose what those networks are, and as long as you run them correctly, you're going to earn rewards from all of them. If you don't run any of them correctly, you may lose your deposit. This keeps the system honest. Nodes that participate actually remain honest. But this massively increases the surface area of innovation. Because now you can build, anybody can build new and interesting services. We call these services, they could be blockchains, but they could be much more generic than blockchains. We call them AVS. Earlier, we used to call them actively validated services, services that need active validation. You need a group of validators to run and validate that network. We've rebranded this to autonomous, verifiable services. Autonomous, they run on their own. What do you mean run on their own? Anybody can come and stake and continue running that service. Verifiable, they don't do the thing correctly, run the service correctly, they're going to lose their deposit and be adjudicated correctly. So you have autonomy and verifiability combined. So that's the idea of restaking. Restaking is you're staking to run more than one service correctly.
That was a great answer. I don't have too much to add, but a word, sometimes I like alternate words. Restake, a lot of people don't know what staking is. Maybe in this audience, they probably know what staking is. But I actually like the word commitments. And I think of restaking, and you use this language a lot, as a self-enforcing commitment system, right? And what are you committing to in this case? In the case of AVSs, you're committing to run some off-chain protocol in a verifiable way.
Awesome. And so my next question is, what are some of the known benefits as well as the potential risks associated with restaking?
I think that the main benefit is that we can build full-stack decentralized apps. I think that we've kind of hit a lull in terms of crypto apps and what's possible with purely just on-chain stuff, right? And what restaking enables is it allows you to write decentralized protocols that can do things like make network requests or open WebSockets or store files or run things on GPUs or do a lot of compute or run things in trusted execution environments. Things that you need to make real applications. And this opens up a wide array of a whole new generation of decentralized protocols.
This is a really interesting point. If you go back to, let's say, 2017, 2018 ETHDenver, you would see a lot of excitement around non-financial general applications. Oh, can I run a Uber on-chain? Can I run a Twitter on-chain? Can I run now AI on-chain, right? These kinds of use cases were in the air. And I think what happened is in the last 7 years, if you go back to 2017, 2018, 2019, the infra was nowhere near ready. You can't build an Uber on-chain. You can't build an AI on-chain. None of this stuff was even conceivable. I think 2025, we're at the point all the infrastructure is ready. You have the ability to, anybody has the ability to build and deploy these autonomous verifiable services. Application builders don't even have to build these services. They can mix and match these services to get the properties that they want. So this is really, really cool. And I think this kicks off the reimagination of what is possible with crypto. Crypto, if you look at why crypto, people say crypto because payment rails, right? Like, yeah, not that interesting. They say crypto because you decentralize it. Most users don't care about decentralization, but they care about verifiable commitments. If an app can make a verifiable commitment, some commitments are so important that they can themselves expand the market. As an example, Uber, right? You want to compete with Uber. You may want to make, Uber is taking now 60% of the fees which go from the rider to the driver. Can you build an Uber which takes 0% and this commission, or only 5% to just sustain the network, this commitment is enforced programmatically on the blockchain. So the set of things that you can build, the benefits of restaking, so to say, or this kind of verifiable commitment system is massive.
I was actually going to add, one of the reasons why Gaia even looked into EigenLayer as one of our main partners is that to be able to restake is so important in the context of building AI applications. And the reason is because you need to make sure that the model or the data sets that you're using is truly who they say they are. And one of the main reasons we took this, if you will, more of a economic or a restaking approach is because as of now, one of our leading thesis is that something like TEE, which requires more hardware scaling, specific types of hardware, it's too binary for being able to handle a lot of context and nuance that requires for AI to be able to serve the end user, which you talked about. So even with an Uber, that decentralized Uber application, there might be some binary decisions to make, AKA drop it here, drop it there, point from one point to a second point. But then if you can even imagine, there's a lot of nuance that happens even within your own journey. New data sets or new information might be introduced because your friend says, oh, actually, can you actually drop me as well off there? And so if you have something that is too, concrete in terms of the settlement process, then it really is not dynamic enough to be able to process these types of AI applications.
Yeah, just to add one more thing on that. Some people ask me this conference, why crypto X AI? Like, what is this? What is going on in this intersection? As all three of us here on stage are very bullish on that intersection and doing different things in various partnerships here. But to make that case, let me just start with crypto has an apps problem. We've all built a lot of infrastructure. Crypto has an apps problem. There are no apps here. There are 4 apps. Bitcoin, Uniswap, Aave, Polymarket. Not enough to sustain our market here. Crypto has an apps problem. AI has a trust problem. Yeah. Intelligence everywhere, non-trustworthy, is catastrophic. AI has a trust problem. AI agents are the new apps. Crypto is the new trust. Crypto XAI is unstoppable.
Amazing. Next question for you, Sreeram. EigenLayer has pioneered a lot of the restaking movement. What lessons have you guys learned since launch, and how has your vision evolved for EigenLayer?
Yeah, so we started EigenLayer. The word Eigen in German means your own layer, open innovation. Anybody should be able to come and build services and applications. This was the original vision. And we named this even before we knew anything about restaking. So EigenLayer is not a restaking project. EigenLayer is a project to maximize the surface area of open innovation. So how do you maximize surface area of open innovation? How do you ensure that? So what we started with is we said, hey, when somebody wants to come and build a new application or a service, they need trust. Where do they get it from? They get it from staking. So there is an already large pool of stakers in Ethereum. Let's rely on it and get the network started. But stakers are only the first side of the marketplace. So we have, like, depending on ETH price, between $13 to $15 billion worth of stake on the EigenLayer platform. The next side is operators. Who is running these services? We have 2,000 operators on the EigenLayer network, starting from regular home operators to the Coinbase and Blockdaemon to Google Cloud running first-party operators. So that's the operator side on EigenLayer. The third side is people building these services. We call them autonomous verifiable services. And we have 100+ services that are being built. The next frontier is apps. So you have stake, you have operators, you have AVSs. Right now, the AVS developer journey sucks. That's why we have this guy here. They're building one of the really coolest platform for expressing and building very complex distributed systems. Building an AVS is kind of like building a whole new layer one. It's a daunting task. You need to massively upskill, uptool, build like very strong developer platforms. So that's one major problem that we have that is being solved as we speak by Layer and using their framework called Waves. And so that's one. The next level is how do you build apps using these AVSs? Apps themselves could be AVSs, but apps could use AVSs. So that's where we are. In fact, one of the things we're doing to like make people reassociate us, not with restaking, but with this idea of verifiable commitments, we're calling EigenLayer the verifiable commitment cloud. It's a cloud, right, like AWS, but it's verifiable commitments where applications, services, stakers all make verifiable commitments.
I will also say that verifiability is so absolutely critical because, again, if you go back to today's analogy, right, if you look at YouTube, it's really hard for you to understand which YouTubers have the verifiable data sets. You might decide by doing your own research, you might decide by just understanding what followers they have, what kind of content they push out. And one of the reasons why I use YouTube as an analogy is that when you look at how the marketplace of AI applications need these very fast, potable context for your applications, you look at how when you go to YouTube, you have a content that you're interested in. You're not going to search for a general YouTuber. You're going to go vertical specific. You might be looking at information such as, hey, I want to buy a car, a Tesla. Maybe you want to then look at vacuums or plants. You're going to go into very specific domains of expertise. And why this is important is because what you've noticed even with the most previous models within ChatGPT, OpenAI's ChatGPT, Google Bard, et cetera, when you're going through this prompting, you will actually see hallucinations, you'll see incorrect information, and sometimes those incorrect information comes from their models being trained on unverifiable data sources. It could be blog posts, it could be content, and I've actually had arguments with my ChatGPT where I said, this is actually incorrect. And they said back to me, yes, I know this is incorrect, but I needed to complete the task. It was the weirdest thing I've ever seen, and it actually freaked me out. But I think that this is why having this verifiability layer in a node network of different models and agents so that you can trust, I think back to what you said earlier, being able to trust AI and truly, truly trust AI. So, yeah.
That kind of brings up a big question of trust is liability. As we make these more autonomous AIs, as AI gets embedded in more and more crucial areas, makes decisions that impacts people's lives or spends a lot of money, how do you handle the liability? This is actually a big question facing the industry, and I think things like verifiable commitments and restaking are the mechanisms by which we can effectively have insurance or liability frameworks for this increasingly AI-driven world.
Awesome, and to expand on Sreeram's last comment on what Jake is building to help new AVSs launch quickly. Jake, can you expand on what you're building at Layer? How is your solution unique? Tell us more about Waves.
It's called Waves, or WAVS. Some people call it WAVs. I personally like WAVs. You can find out more at waves.xyz, WAVS.xyz. What it is, it's a WASI AVS runtime. I'll unpack that a little bit. We've talked about AVSs. WASI is WebAssembly System Interface. So what we try to make it as we try to really improve the developer experience so that you don't have to worry about writing code that listens to RPCs from different chains, right? You want to listen to events on Base or Arbitrum or a Cosmos chain or Solana, right? And have that trigger some action, right? You don't have to write that logic, right? Doing things like off-chain triggers or scheduling. This is all parts that you would have to write previously to make an AVS. We also had, we basically make it so that you only have to write your application logic in these WASI components, which you can dynamically deploy to the service without having to coordinate with your operator set on an upgrade. And then we also, on the other side, on the submission side, we handle signing the outputs with BLS signatures, aggregating those signatures and submitting them on chain. Or potentially, we also introduce a new thing called composition, because these services are really great. It's much more interesting. Okay, we got a ZK TLS service, and we got an AI agent service, and we got an Oracle service. Standalone, they're very useful, but if you can combine them together and compose them in verifiable execution flows, that's when we get to the next level meta, and that's what's going to enable us to build the next generation of great crypto apps and user experiences, is these kind of intelligent protocols.
That's really crazy. I didn't know that, the composition framework. So one of our vision for thinking about how, one maybe metaphor I can start with, is when you think about web application development, imagine it's 1995. I know most of you are not old enough to have lived through that, but some of us here are. So in 1995, if you want to build a web application, you have to either go build your website on some very stock application like GeoCities and then just do a static web page. Or if you're building something very complex and dynamic, you have to build your own server, build your own database, build your own payments, identity, everything. Whereas in 2025, you would absolutely just use the cloud, use OAuth for authorization, Stripe for payments, MongoDB for database, mix and match them. A typical application on the web application uses 15 SaaS services in the back end. And some people say, oh, when you have many modules in crypto, is there going to be enough fees? The largest venture-backed investment area in the last 20 years is software as a service. And the reason is software as a service means you're hyper-specializing in providing a useful utility for everybody. And so that's what we think of AVS as. Can we have AI inference, which is a very fundamental core AVS that will help everybody build new and interesting apps? So, but when these can be composed, you get some superpowers.
And last question, we have about 2 minutes left. Why should AI agent networks leverage restaking and restaked assets?
I think that in this kind of journey that you've been painting about where we are in the development cycle of applications, autonomous applications, AI applications, one of the main reasons why we chose restaking for our node network is because something I kind of alluded to earlier. There's two main reasons. What I alluded to earlier was a lot of the leading security and verification, let's say it's TEE, is still very hardware. It requires a lot of hardware considerations, and it makes scaling very difficult. By design, what we wanted to do was make sure that you are not locked into whichever vendor. I think you talk a lot about modularity. So modularity is very important in being able to handle dynamic context and dynamic data and information that is input into your application. Another reason why is because we don't need humans to, what we're looking for humans to do, frankly, in the process of staking, voting, kind of the operator set, is that we're still building out the application layer stack. If you're creating AI for humans, because at the end of the day, what are we creating AI for? It's to really improve the lives in our own workflows, right? And so as we're in this process, we really believe that restaking is able to handle the dynamics of security requirements. And then number two, there's human interaction to help design the right UX layer and the right workflow automation that is truly needed for us here.
Real quick, I think it's how you actually make decentralized AI. And why does that matter? Because maybe decentralization is too abstract of a concept for many people, but it's really simple. It's about the terms of service. And if you don't have, if it's not decentralized, then you're using some other terms of service, right? And I, for one, would rather live in a free world and not be a techno-feudalist serf.
Like a centralized AI marketplace, and if you stop paying subscriptions, they'll take it away, and then you won't have your memory. Wow.
Awesome. So unfortunately, that's the end of our panel, but I'd like to thank all of our panelists here for contributing and our audience here for tuning in. Thank you, everybody, and hope you enjoy ETHDenver.
Thanks, everybody.
Thank you so much, Alexis. Thanks, everybody.